Hello students, in today's class we'll discuss about properties of inverse trigonometric functions. So first we'll discuss these properties. Number one, sine inverse sine theta is equal to theta belongs to minus pi by 2 to plus pi by 2. In earlier classes we have studied principal value branch. So in principal value branch only, sine inverse sine theta is equal to theta if theta belongs to minus pi by 2 to plus pi by 2. Second property, second one, quickly I state this, cos inverse cos theta is equal to theta. Here theta belongs to the principal value branch is minus 0 to pi. 0 to pi. Then third one, tan inverse tan theta is equal to theta. Here theta belongs to open interval minus pi by 2 to plus pi by 2. Number 4, cot inverse cot theta is equal to theta. Here if theta belongs to open interval 0 to 1. And fifth one is sec inverse sec theta is equal to theta. What is this principal branch? Principal value branch. Theta belongs to 0 to pi minus pi by 2. And sixth one is cosec inverse cosec theta is equal to theta. Theta belongs to minus pi by 2 plus pi by 2 minus 0. So this is the principal value branch in this domains only. When theta lies between minus pi by 2 to plus pi by 2, then sine inverse sine theta is equal to theta. If theta lies between 0 to pi, then cos inverse cos theta is equal to theta. So similarly, these are. So you have to remember this happens only in the principal value branch. If it is not in the principal value branch, this will not be there. So in that case, what will happen? That will also will plan. First, let us do one example. So sine inverse sine pi by 6 is equal to simply pi by 6. Since pi by 6 belongs to minus pi by 2 to plus pi by 2. Similarly, if we say sine inverse sine minus pi by 3 equal to what? It will be minus pi by 3. Same reason, since minus pi by 3 is inside, minus pi by 3, minus pi by 3 belongs to this one, minus pi by 2 to plus pi by 2. Now this will happen when theta is inside minus pi by 2. If this one, it is not inside, this interval. Suppose say sine inverse sine of 3 pi by 4 equal to, according to this formula, this should be 3 pi by 4, but 3 pi by 4 does not belongs to this one, so it is not equal. Sine 3 pi by sine inverse sine 3 pi by 4 is not equal to 3 pi by 4, since 3 pi by 4 does not belongs to minus pi by 2 to plus pi by 2. So what it will be actually, what it will be sine. So we make this angle, this one 3 pi by 4 belongs to this interval, which is minus pi by 2 to plus pi by 2. So for that, how to do? So sine inverse, you can write like sine inverse sine 3 pi by 4 equal to, you can write sine inverse sine pi minus 3 pi by 4. We can write, because sine pi minus theta, since sine pi minus theta is, since sine pi minus theta equal to sine theta, we know. So we have to use this formula. So since sine pi minus theta is equal, so using this one, we can write sine inverse sine pi minus 3 pi by 4. In place of sine 3 pi by 4, we have written sine pi minus 3 pi by 4. So as a result, this is equal to what? Sine inverse sine pi minus 3 pi by 4 is equal to pi by 4. Now we can write this is, now we can apply this sine inverse sine theta is equal to theta if theta belongs to minus pi. So now pi by 4 belongs to, now pi by 4 belongs to, since pi by 4 belongs to this minus pi by 2 to plus pi by 2 for sine function, sine inverse function, theta should be belongs to minus pi by 2 to plus pi by 2. So theta is here pi by 4, and pi by 4 belongs to minus pi by 2 to plus pi by 2. So this is the answer. Sine inverse sine 3 pi by 4 is equal to sine pi by 4. So this is very important. In this way, for other trigonometric functions also, we can do the same. Now another type. Now another property. Now we'll do another property. Says sine inverse, sorry, sine of sine inverse x is equal to 1. Sine of sine inverse x is equal to x. Here x belongs to this closed interval minus 1 to plus 1. Number 2, cos of cos inverse x is equal to x. Same, x belongs to minus 1 to plus 1. Then only if x lies between minus 1 and plus 1, then this will be x. Otherwise, no. Number 3, tan inverse x is equal to x. This is true for any real number. This is true for any real number. Number 4, cot inverse x is equal to x. X belongs to any real number. Number 5, sec inverse x is equal to x. X belongs to r minus open interval minus 1 to will be a number between -1 and +1. Minus if x is between -1 and +1, then we cannot find sec of sec inverse sec. It is not defined. It is not defined. Number 6. Cosec inverse x is equal to x, same interval, x belongs to or minus 1. So these are the properties of sine inverse function properties. So let us try to illustrate this with the help of examples. Sine inverse half is equal to, what do you look at? Is equal to obviously half. Now another type of question is there. Another type of question is half is belongs to -1 to between -1 and +1 closed interval. So sine of sine inverse half is equal to. Now if it is something like this, sine of cos inverse half equal to, then what? So we have to change it to cos inverse half into sine inverse half. So how to do this? This can be done very easily. You remember this one is right triangle cos inverse half. So if we take let cos inverse half is equal to theta, this implies cos theta is equal to half, and we know cos theta is equal to for base by hypotenuse. So base by hypotenuse we take as 2 and base as 1. In that case, this perpendicular becomes 2 square minus 1 square, that is 3, so root over 3. So this is equal to root over 3. In that case, this one we have to do like this. So therefore, sine, so this is equal to, we can write it as sine cos inverse half is equal to, we can write it as in terms of sine inverse. So this is equal to sine inverse root 3 by 2. Root 3 by 2. Because we have cos theta is equal to half, then sine theta is equal to root 3 by 2. Sine theta is equal to root 3 by 2. If this one will be theta, then sine theta is equal to root 3 by 2. Cos theta is equal to half, so sine theta is equal to root 3 by 2. So cos inverse half is nothing but is equal to sine inverse 3 by 2. So this is equal to now root 3 by, we know root 3 by 2 belongs to -1 plus 1 close interval, -1 plus 1. So sine of sine inverse 3 by 2 is equal to root 3 by 2. So we can do any example like this. So let us try another one. Sine of say cot inverse 3 by 4, something like this. Cot inverse 3 by 4. So it's equal to what? Cot inverse 3 by 4. So obviously we can draw a triangle here for cot theta. Cot theta is here cot inverse 3 by 4. So we have to take cot theta. Cot theta is equal to base by perpendicular. Base by perpendicular. So here it is 3 and this is 4. The perpendicular is base is 3 and the perpendicular is 4. So hypotenuse will become 3 square plus 4 square, 9 plus 16, 25. So this is equal to 5. So this is equal to hypotenuse is 5. So in this case, we have to write in terms of sine. Now, sine is equal to sine cot inverse 3 by 4. Cot inverse 3 by 4 can be written cot inverse 3 by 4 is equal to sine inverse. We can write in terms of sine inverse. Sine inverse sine theta is perpendicular by hypotenuse. So perpendicular is 4, hypotenuse is 5. So it is equal to 4 by 5. So it's equal to 4 by 5. So it is 4 by 5. So in this way, we can solve this type of problems very easily. Now we can generalize the statement like this. Sine inverse. So sine inverse is always comes as perpendicular by hypotenuse. If angle is like this is perpendicular, this is hypotenuse, this is base. Now sine inverse b by h can be written as cos inverse b by h is equal to tan inverse. Tan is perpendicular by b by b is equal to cot inverse b by b is equal to sec inverse h by b is equal to cosec inverse h by b. So you can remember this one. So this will help in solving various type of inverse symmetric function problems. So I hope you understood these two properties. They are very important for solving the problems. Other properties are also there that we will discuss in the next class.